So to start off with, it says, over a long period of time, it has been found that in Enrico's restaurant, the ratio of non-vegetarian to vegetarian meals is 2:1. In Manuel's restaurant, in a random sample of 10 people ordering meals, 1 ordered a vegetarian meal. Using a 5% level of significance, test whether or not the proportion of people eating vegetarian meals in Manuel's restaurant is different to that in Enrico's restaurant. So it mentions here that test whether it's different, not whether it's more or less, but different, meaning that we've got ourselves a two-tailed test here. So how would we start this off? Well, first of all, we need to work out write down some parameters and work out what the probabilities and so on are. So first of all, we'll say let X represent the number of people in the sample at Manuel's restaurant who order vegetarian meals, since we are doing a test on Manuel's restaurant. So number of people who order vegetarian meals. So then we can say X is approximated by binomial distribution with, well, how many people? Manuel's restaurant, random sample of 10. So we've got 10 as our sample size. And what is the probability that is currently assumed to be true for people who are ordering vegetarian meals? So what is P, the probability of people ordering vegetarian meals? Well, let's see. It says here, in Enrico's restaurant, the ratio of non-vegetarian to vegetarian meals is 2:1. So non-vegetarian is 2 parts, vegetarian is 1 part. So I'll just write that down here. Non-vegetarian to vegetarian is 2:1. So the probability of someone being a vegetarian is 1 out of a total of 3, because there's 1 part out of a total of 3. So probability of someone ordering a vegetarian meal is assumed to be 1/3. Okay, so a bit of working out needed to work out the probability. It wasn't given to us straight away. That goes here, the probability of someone ordering a vegetarian meal. So there's my binomial distribution to begin with. Then I go and write down what my H0 is. H0 is that the probability of someone ordering a vegetarian meal is assumed to be 1/3. H1 is that the probability of someone ordering a vegetarian meal is not equal to 1/3, not greater or less. It's because of the word different mentioned here. We say it's not equal to 1/3, and this is where we've got our two-tailed test. We're going to do a test at 5% significance level, so I'll just make a note of that here. Significant level is 5%. Okay, so let's go and see what if there was any kind of a test statistic mentioned here. It says in Manuel's restaurant, in a random sample of 10 people ordering meals, only 1 ordered a vegetarian meal. So only 1 ordered a vegetarian meal. So let's go and write down our number line here, all the way up to 0 to 10 people that could have ordered a vegetarian meal. And only 1 ordered a vegetarian meal. So we'll look at the lower tail here. We'll look at this lower tail here first. And it could potentially, we could have an upper tail as well, but we'll consider the lower tail here, 0 to 1. So 1 person ordered a vegetarian meal. So remember, our calculator can work out less than or equal to 1. X is 1, N is 10, P is equal to 1/3. Type that into our calculator, and it would give us a figure of 0.104. Okay. And we want to compare this to our significance level. Now, remember, this is a two-tailed test. And since we're considering the lower tail here, we need to then either half our significant level here or double this probability here to compare to the 5%. One or the other, not both. So in this case, what I'll do is I'll half my significance level. So half of 5% is 2.5%. So then 2.5%, I'm going to say that, first of all, this answer here is 10.4%, which is less than the 2.5% significant level. Sorry, 10.4, which is greater than the 2.5% significant level. So since it's not less than the significant level, there is insufficient evidence to reject the H0. I only needed to do my testing at one side on the one, because they gave us a value of 1. It was the 0 to 1 side. If they gave us a value of, let's say, 8 people ordered a vegetarian meal, then I'd look at the upper end, 8 to 10. Okay, I'm looking at the end, 8 to 10, that end, or if it's a smaller value, you look at the lower tail. If it's a high value, you look at the higher tail. That's how you deal with the two-tail test. So here, we don't need to check the upper tail. This is enough to then go and say, actually, there is insufficient evidence to reject H0, which means there is no evidence that the proportion of people eating vegetarian meals in Manuel's restaurant is different to Enrico's. So not enough evidence to say that proportion of people eating vegetarian meals in Manuel's restaurant is different from Enrico's. So we need to make sure we write a conclusion statement in the context of the question. The question then goes and asks us something else here. It goes and asks us to state the p-value of this test. Remember what I said earlier about the p-value? The p-value is the probability that we worked out for the test statistic times by 2. So the probability that we worked out was 0.104 from here. So part B here is the p-value is equal to 0.104 times 2. Okay, so that is 0.208. And then you could have compared this p-value to the significance level of 5%. So you could have then said that this is 20.8%, which is greater than the 5% significance level, which is another way of then doing the hypothesis test and making that final conclusion.